My name is G. Sindhuja. Today I am going to explain about my seminar topic on examples of recursive algorithm. Contents: definition, advantages, disadvantages, applications, components, examples of recursive algorithm. Definition: a recursive algorithm in the simplest terms is a method of problem solving where the solution to a problem depends on solution to smaller instances of the same problem. It breaks down a problem into smaller and smaller subproblems until it gets a problem that is small enough to be solved easily. Advantages of recursive algorithm. Recursive algorithm make the code look clean and elegant. A complex task can be broken down into simpler subproblems using recursion. Sequence generation is easier with recursion than using some nested iteration. Disadvantages of recursive algorithm. Sometimes the logic behind the recursion is hard to follow through. Recursive calls are expensive as they take up a lot of memory and time. Recursive functions are hard to debug. Applications of recursive algorithm. Sorting algorithm, tree and graph data structures, dynamic programming. Sorting algorithm. Recursive algorithm drives some of the most efficient sorting algorithms in computer science, such as merge and quicksort. They utilize the divide and conquer strategy to divide the data set into smaller subsets, recursively sort them, and finally reassemble them into a sorted whole. Tree and graph data structure. Recursive algorithms are extensively used in various operations involving tree and graph data structures, be it performing depth first search and a graph or traversing a binary search tree. Recursive algorithm provides the simplest and most intensive solution. Dynamic programming. Recursion plays a crucial role in dynamic programming, a method used for solving complex optimization problems by breaking them into simpler subproblems. Recursive algorithm aid in defining the optimal structure of the problem which perform the correct dynamic programming. How to write a recursive function. Components of a recursive function. Base case, recursive case. Every recursive function must have a base case. The base case is the simplest scenario that does not require further recursion. This is a termination condition that prevents the function from calling itself indefinitely. Without a proper base case, a recursive function can lead to the infinite recursion. Recursive case. In the recursive case, the function calls itself with modified arguments. This is the essence of recursion, solving a larger problem by breaking it down into smaller instances of the same problem. The recursive case should move closer to the base case with each iteration. Let us consider the example of a factorial number. In this example, the base case is when n is 0 and the function returns 1. The recursive function multiplies with the result of the function called with parameter n minus n. The process continues until the base case is reached. It's essential to ensure that the recursive function has a correct base case and that the recursive calls leads to the base case. Otherwise, the procedure might run indefinitely, leading to a stack overflow below the implementation of a factorial number. In this program uses a recursion to calculate the factorial of a number. In main function, get a number from the user number input. If we enter a non-negative integer, then get the factorial of the number. Fact equal to factorial number. Display the factorial. Print. If we enter print the factorial of a number is fact. The factorial function uses a recursion to calculate the factorial of its argument, which is assumed to be non-negative, and definition factorial number. If we given num equal to 0, it returns 1. Also return num equal to factorial n minus 1. Call the main function. In this, it gives the output as if enter a non-negative integer 4. The factorial of 4 is 4 into 3 into 2 into 1. Then the final output is 24. In the sample of the given program, the factorial number is call the argument 4 passed to the number. Return num equal to factorial num minus 1. Although this is a return statement, it does not immediately return. Before the return value can be determined, the value of a factorial number minus 1 must be determined. The factorial function is called recursively until the fifth call, in which num factorial will be set to the 0. It illustrates the